We're very happy today to welcome to the FDTD Satellite Application webinar, Derek Williams, who is a forecaster in Elko, Nevada, but he's also an IMET. That's what we'll be talking about today. Derek started his National Weather Service career in the office where the National Weather Service day begins. That is Guam back in 2008, and he moved to Elko in 2016. Next slide, please. This is part of the FDTD Satellite Applications webinar. We have a website that's shown at that link. I'm Scott Lindstrom. Dan Bykos and I coordinate these. If you ever want to volunteer to give one of these presentations or volunteer someone else to give these presentations, please send us an email if you have a case where satellite imagery was very useful to whatever application you're using. Next slide, please. Just some protocol. We'll have about 20 minutes for Derek to talk. You can send questions to the GoTo chat, or you can ask via your computer at the end of the talk. We should be done by about 18:30 UTC. Don't press hold and mute when you're not speaking. Take it away, Derek.
All right, thank you, Scott, and thanks, Dan, for having me today. Like I said, or like Scott said, I started on Guam, and I had an advantage because Scott came there years ago and kind of trained us up on the Himawari 8. So when I eventually moved to Elko, Go 16 and 17 were a breeze. So thanks, Scott. And so I'll go ahead and get started here. I moved to Elko in 2016, started training for the fire weather, and IMET, or incident meteorologist. There's quite a bit of training that goes on. And got certified in 2017. So this will be, I think my fifth or sixth year as an incident meteorologist. So hopefully I can provide a unique perspective on how we utilize GOES on a fire incident, specifically on fires. Okay, so what is an incident meteorologist? We are ordered or deployed to provide meteorological decision support to Type 1 and Type 2 incident management teams, or IMTs. These are interagency, a lot of times federal, sometimes state teams that organize to kind of manage these large-scale fires, especially in the West. Firefighter personnel safety is priority. Usually deployed on site for 2 weeks with 16-hour days. So I wake up at 4:30 and go to bed at 10. And the bed consists of a tent and maybe a pillow if you're lucky. So it's not the best sleeping conditions, but you know, our work site is only 5 minutes away, and we put in some good time there. Sometimes it can go longer than 2 weeks. I did a 21-day deployment to the Caldor fire in Sierra Nevada. So I'll talk about that. That's one of the fires I'll talk about. Weather has a significant impact on wildfire growth and evolution, and also on operations of the team, firefighting personnel, all the equipment, etc. If you look to the right, you'll see what we call the fire triangle. Topography, that doesn't really change. Hopefully it doesn't change when you're there. Fuels don't change as fast as weather. So weather is I guess, the most diverse and changeable element in this fire triangle. GOES and POES utilized in many situations, well, basically in all situations. GOES is increasing among fire personnel and incident management teams. I haven't been to a fire yet where they don't immediately show me the satellite. So firefighters are very weather savvy. A lot of them are, especially what we call F bands, which is our kind of partner when we're on a fire. Fire behavior analyst is the is the name for it. So fire behavior analyst and the IMET kind of work on basically where the fire is going to go based on the weather and fuels. Okay, let's start with a Bootleg Fire. Bootleg Fire was a 400,000 acre fire. And to give you perspective on that, what is 400,000 acres? So when I was on Guam, Guam is 212 square miles or 135,000 acres. So I don't know, 3 times as big as the island of Guam. And a lot of it was a pretty bad burn or high burn severity. It was in heavy timber. Lightning caused fire, South Central Oregon in the Fremont-Wenema National Forest, or what was the Fremont-Wenema National Forest. A lot of it got burned up. It's not as bad as it sounds. It does recover, but things are changing. The antecedent conditions, unprecedented in late June, early late June, heat wave, 110 degrees in many of the valleys in Oregon. It was stunning. From even we were watching it from our office in Elko, and we just couldn't believe the temperatures. And of course, we're like, well, in a few weeks that area is going to burn, and sure enough, it did. So emergent, extreme, exceptional drought conditions in the area in and around the Bootleg Fire, and you can see that on the green arrow on the right. Timber drier than processed retail lumber. So there was a story that there is some private timber sales there. They were cutting down trees, and they were able to get 2 or 3 more logs on these tractor trailer units than what they normally could, because the live tree fuel moisture was lower than when they post-process it. So they may have had to add moisture to this. It was pretty stunning. Tens of thousands of acres per day in burn coverage. And July 18th, that was a unique weather event with multiple fire whirls. So I'm going to go kind of a day-to-day progression, and then I'll show just a kind of a animation of the day. July 14th, this is a couple days after I got there. That yellow star you see is where we did our briefings to the fire crews. And so I had this unique perspective where I could actually see what was going on the ground and kind of correlate that with satellite. And so each of these, the ground-based picture and the satellite picture, are almost around the same time in most cases in the next few slides. So, and on the right, you can see some lightning being produced. So it was a pyrocumulonimbus. And there was one case where the lightning was 7 miles east of the main fire front. So we were concerned of additional fire starts from this fire. Pretty amazing. So here's a couple days later. This is just day to day. It was pretty incredible as far as the progression. Unless they were going to stop it, it was just going to keep going and going and going because the fuels were so dry. And the winds, we had a high pressure or kind of a heat low develop each day over the Great Basin. So, you know, southwest to northeast flow around that high pressure, Four Corners high situation. And the winds weren't too strong, you know, 15 to 20 miles an hour, but that was enough to progress it each day. July 17th, again, you will notice that it's more elongated. So we were seeing an approaching trough into coastal Oregon at the time. So those winds were picking up aloft. Excuse me. That eventually produced 40,000 foot Pyrocu, and that was pretty amazing. July 18th, this is where the fire rolls developed, and this was around 6 p.m. And you'll see some monsoon moisture starting to emerge in the southeastern part of this satellite picture, and that kind of a harbinger of things to come. as far as some much needed moisture, at least on a short-term basis. So here's the radar picture of the rotation on the lower left panel. The radar beam height was fairly high. I think it was several thousand feet, so it wasn't capturing this small scale event too much. But even so, this is very impressive, and you'll see in the next few slides what this resulted in. Here's a closer view of it. So you see that kind of gate-to-gate shear develop there within this pyrocumulonimbus. And there's a result. Multiple fire whorls, vortices. This is the northernmost damage path, if you will. Estimated EF2 damage based on the EF scale damage indicator, number 28. That was the only indicator we had at the time, because fortunately there wasn't a whole lot of structures or infrastructure within this area. But you could sure see the devastation caused to the forest. Here's a closer look at a second fire whorl incident. Large tree swaths blown down ahead of the fire front. You notice these were live trees. So this vortice developed well ahead of the fire front by several hundred yards and just kind of ripped through there. You'll see a debarked tree if you look closely on the right picture in the background. Pretty impressive stuff. In the middle picture, the asphalt was ripped up off of the road. So these fires, whenever you get these high fire intensity, it could really just mess things up. You could get these fire whorls that we think they're fairly common. A lot of times these happen and the fire moves over the damage path, so the damage is kind of erased. But in this case, it was a unique opportunity to go see this. July 19th, here's the moisture, much needed rain. When we say much needed rain in the West, we mean a few sprinkles, especially in July, but we'll take what we can get. Excuse me. The main issue was the higher humidity. I think the humidity that day, instead of you being 10%, it was 15 to 25%, and that was enough to kind of help things out fire-wise, and especially the cloud cover as well. And by July 20th, everything was kind of calmed down. They had caught the fire, so to speak. A lot of the smoke that you see is interior, what we call interior burning. It's not along the main, fire front where there's fresh fuels to burn. So not too concerning. They did stop it, and they did a excellent job. It was a tough firefight, and if they hadn't stopped it, it would have continued eastward into an area that hadn't burned in an estimated 300 years. That smoke that you see on the lower portion of this is from the Dixie Fire, an emerging incident at the time. And you can see kind of the remnant monsoon moisture, showers and thunderstorms across much of Lake County east of the fire. Okay, here's a mesoscale sector animation. We use this quite often. In fact, this was put up on the 20-foot screen in our what we call incident command post in our area. We were in a school cafeteria at the time, and they just happened to have a projector, and that's what everyone watched was a satellite. So like I said, satellite's a very important situational awareness tool for the firefighters. So this is just visible. We usually have 4 panels with the fire temperature, 3.9, all that other stuff, all the RGBs. But this is kind of just easier to see. Now, the lightning that you see is from the ground-based lightning networks. COD has a nice feature where you could see the GLM data. and I use that quite a bit too. I just didn't save the animation. So fortunately, the mesosector was available almost every day. I think it is parked over that area anyway, but we had this resource, which was it was a needed resource. You would think the minute data wouldn't be needed too much, but it was. It aided in identifying the onset of increased fire behavior during what we call the burning period, or the beginning of the burning period. And usually it's a 6-hour period, but in this case it was just a little bit longer because of the fuel conditions. And the burning period is basically when things are ready to burn and then the fire propagates easily. 3.9 shortwave. Of course, this is the, I think, natural color, no, true color, RGB. And it's easy to differentiate between the smoke and the pyrocumulus in this image. And then there's the 3.9. And believe it or not, we could actually estimate the fire progression distance each day just based on the 3.9. And we estimated 3 to 4 miles per day during that active week with those consistent southwest winds. So that was a neat thing to see. Of course, the derived products, firepower, fire temperature, we utilized all those as well. And you'll notice that I'm using the COD weather. A lot of times when you go to the fires, especially type 2 incident management teams, they don't have, they have satellite-based internet, and it's not as fast as we want. So COD weather is kind of a low bandwidth solution. Whatever way we can get the satellite data is you know, the kind of the main thing to go to. So Bootleg Fire, kind of a wrap up of it. Max intensity around 6 p.m. That's when we see the highest cloud tops and the most active fire behavior and the most the highest cloud tops. Goes early detection of the lifting inversion every day in the valleys. There's an inversion. Planetary boundary layer mixing during the day, and eventually gets you know, that dry adiabatic almost every day up until the top of the boundary layer. So that process we could kind of use GOES as a proxy to find when that occurs. So smoke dispersion as well. There was if I go back to this one, you'll notice that this lower level smoke kind of on the right there on the southeast portion of the fire itself, you'll see that lower level kind of layer of smoke move from north to south right there. And by 9 p.m. we had choking smoke in Lakeview, Oregon. That's where our ICP was. So that was we could time that pretty well, and it kind of dissipated after a couple hours. So that was another thing we could identify. Daily progression. Of course, in absence of cloud cover, a lot of times, especially in this time of year, it's cloud free anyway, so that's good, with the exception of the pyrocumulus. Bandwidth challenges, COD weather, other internet sources. Although we are having a kind of a new AWIPS. It's basically a virtual AWIPS that I think is very promising as far as getting satellite data. Getting satellite data more quickly and within the AWIPS platform. GOES is widely known in the fire community, and smoke impacts near the surface. Caldor fire. We'll go to this one, and no surprise there. California's in a drought. In fact, kind of very similar to the Bootleg Fire, the West in general has been in a severe to an exceptional drought in many locations. It is starting to wane, but this is what it was during this time in mid-August. So it was a 200,000 acre timber brush fire in the Sierra Nevada range. A very sensitive ecological and economic area that extended into the South Lake Tahoe Basin. And South Lake Tahoe is a very important tourism area. A lot of skiing in the winter. Of course, they have the casinos there, so it was it was critical to protect that. So they eventually halted the progression in October. Well, really earlier than that. It was just kind of progressing slowly after late August, but October pretty much done with some smoldering continuing. Pressure to repair rehab to the extent possible before winter. And the IMTs, or incident management teams, remained through late October 2021, and that's when I was there. Snow, yeah, snow and firefighters, do they mix? Well, sort of, kind of. We'll see. So there is a lake effect snow band. This was a cold front that moved through, and this was, I don't know if there's a time here. Let's see, 1638Z. So this was 16. It's like 8:30 in the morning. North to south frontal passage on October 11th. I was curious on lake effect snow. I didn't know too much about it, especially in the west and especially at Lake Tahoe. So coordinated with Reno Weather Forecast Office on lake effect snow occurrences, and they happened to give me a paper on it, and I read through that paper, and sure enough, the conditions were there. And a couple of days prior to this event, I was saying, hey, there's gonna be some lake effect snow. It's gonna affect operations significantly. So accurate timing of snow was pretty much spot on, thanks to GOES, and you'll see that in the next slide here. So I labeled the cold front. The cold front is right on the upper left part of the C, and it kind of just hung up in mid Lake Tahoe in the early morning hours before sunrise. Then it started to progress southward towards South Lake Tahoe, KTVL, and by 9, 10 a.m. it's well to the south. Now, if you'll notice on Lake Tahoe, you'll start to see this convection develop right there. And then it kind of streams southward. And I think there's some parallax error here, but it was right over the airport. This band was right over the airport. They ended up getting 5 inches of snow. And where we were located, just 3 miles to the east, we didn't get a whole lot. So, or at least it melted more quickly. So, yeah, it was a narrow band, but it significantly impacted travel, especially for the firefighters. In fact, by mid-morning, because of the GOES imagery, as long as I saw that, these developing convective bands at mid part of the lake, I was like, this is going to continue. So I sent out a radio update, and they basically just halted all operations because they couldn't get anywhere. There was only one point out of South Lake Tahoe, so there was a choke point, and it just didn't work out, and operations were shut down for the day. Excuse me. Snow event lasted well into late morning. In fact, I think it lasted through the early afternoon. Issued radio update and halted operations, and narrow band right over the main travel corridor, and operations resumed the following day. And I think that's it. And if I'm sure everyone's kind of familiar with this image. This was in September 2020, whenever they had those large fires in California and Western Oregon, the Cascades area. I showed this at the cooperators meeting, which is kind of a typical meeting that we have during our IMET deployments. Sheriff's office, emergency management officials, county officials, etc. Those kind of people are on the calls, and they were just amazed. They were amazed with this picture. It's easy to differentiate between the smoke and the clouds, even to an untrained eye, so to speak. So, with that, is there any questions?
Thanks, Derek. I see a couple questions, but I'm going to ask one first as host prerogative, I guess. So when you're in the field, were you using the thin client AWIPS and you're going to be transitioning to AWIPS in the cloud? Was that my interpretation of what you were talking about with bandwidth?
That is correct. That virtual environment basically just streams the desktop of the remote client. So it takes significantly less bandwidth. In fact, I think I was running it only on 5 to 10 megabits per second into camp, and that's spread out over 100 people. So with thin client, it just wouldn't work.
Well, that sounds good for next year then.
It is, yeah.
So the people from Glasgow have asked, do you have have you seen any good radar examples of a collapsing pyrocumulus on radar? Maybe they're talking in the context of, I don't know, gusty winds or something like that, but have you seen any examples of that when the pyrocu collapses and you're viewing that on radar?
Not on radar. I think there was a time-lapse webcam. There's webcams, BLM webcams and Forest Service webcams all over the Western U.S. And you could see time lapses, and you could see these collapsing columns, but I haven't seen an example on radar yet. I would assume there would be some mid-level convergence, to indicate that kind of collapse. There may have been. I'll have to talk to a few people. I can get back to you on that one.
Another question is so you mentioned tracking the fire using satellite, and I think you showed some examples of using the visible. There's also the fire RGB, so a multispectral type of look. Did you use that also? And I'm just kind of curious as I ask this if you had the bandwidth to use to look at it, or if just the visible imagery was choking things bandwidth wise.
No, we use Fire RGB and all those other derived products. I just didn't have an animation of that one.
Right.
There's some great examples on the Sims blog. I didn't want to regurgitate it here, but I think there's one on the Bootleg Fire and even one of the Caldor Fire. So if you want to see examples of kind of an active fire with those types of products, that's a good source.
Okay, thanks. And I have another question about when you're looking at the moisture as it's coming in, are you looking at really just like the character of the convection in the visible, or are you looking at level 2 products like there's a TPW product that you can see in clear air that would indicate more moisture coming in, or is it more just a feel of the character of the convection and the air mass that's approaching, if you know what I mean?
Well, we also put up soundings on site, so a lot of times we can see kind of, especially if we're upstream of the fire, we can kind of see that moisture coming in, but we rely on that a lot. I haven't looked at the TPW products a whole lot. A lot of it's experience. You see the mid-level cloud cover. It's just almost a pretty good sign that convection is going to happen during the day. So, and that's what happened on the Bootleg Fire. So, a lot of times we also rely on the HER, especially if before our morning briefing at 6 a.m. or 7 a.m. We can utilize that and really hone in on the timing and coverage of convection.
And there's a question here from Frank in Colombia. Do you use the day-night band from NOAA 20 at all? And maybe that's a question about tracking smoke at night, which is a historically difficult problem.
Yeah, well, I haven't, but once we get this cloud AWIPS in the cloud going, I think we're going to have some more options. And another thing we utilize is the POSE platform, the MODIS imagery.
Right.
A lot of times we're concerned about fire progression. on the ground, where it's going, if infrastructure is impacted, houses are impacted. So we utilize the MODIS DTEX, the IR DTEX, and that's a higher resolution than the GOES. So, but that's only, I believe, 6 hours. And we also have infrared flights almost every night. And usually those are between 10 p.m. and 2 a.m. Basically after that burn period ends. And you could see where the heat is located. Okay, that heat, whether it be isolated heat or scattered heat or widespread flames, determines what's going to happen the next day. So that's another resource we use for fire progression. That's more on like the fire behavior side, but I use it all the time for situational awareness.
So those IR flights, are those like dedicated aircraft that you control, or are these coming from something different?
It depends. So the Bootleg Fire, for instance, it's a typical infrared flight. I can't remember what they call it. It's an infrared package on a fixed wing aircraft. They fly at a certain altitude. They go over the fire, scan it, and send that data back to an interpreter, and that interpreter sends out a report, typically a couple hours after the data comes in. On a Type 1 incident, for instance, CAL FIRE or these large fires that destroy many homes, they actually have 24/7, almost 24/7 coverage of a UAS platform. So they have a M9 Reaper drone repurposed for IR flights, and they continuously scan this fire. And typically they have live feeds that come straight into the operations area, and so we can see those. And that's instead of every 6 hours, with a MODIS, or every 24 hours with a standard IR flight, we can get updates whenever you want, every 2 or 3 hours on a specific location. So it just depends on the scale of the incident.
Cool, I did not know that. I don't see any other questions, and I'm mindful of our time. So I'll give 30 seconds if you want to ask a question, type it on in. Otherwise, oops, I see, well, no. I'll just say thank you, Derek, for an interesting talk. I learned stuff, so that's always useful. We do have another FDTD webinar next week, next Wednesday. Brian Haynes and Dave Riddell from Mount Holly and Upton on the East Coast will be talking about floods associated with Tropical Storm Ida. So we hope to see you next week, same time. Thanks again, Derek.
Well, thank you. Thank you for having me.